would like to introduce you to Senthil Kumar Ganesan. He's a member of the technical staff at Dell. He spent the last 15 years working in the networking industry, and the last 4 of those years working on open source network operating systems. Today, he's going to be talking to you about demystifying open source network operating systems. Senthil?
Thank you, Michael. Good morning and welcome to NANOG 79. Before we begin, I would like to express my sincere thanks to all the frontline workers and prayers to those who are affected by COVID-19. It is hard not to be connected in person, but I'm happy that we could connect virtually. In the 21st century, knowledge and know-how are the keys to success. Let's together demystify the open source network operating systems. I'm honored to be presenting here and fortunate enough to work on most of the open source operating systems. I hope you find it useful. Thanks for your time. I'm happy to answer any question at the end of the session. Since this is an introductory talk, I would like to take a moment to quickly talk about disaggregation and open networking before we dive into open source network operating systems. What you see on your left is a traditional integrated solution. Hardware and software comes from the same vendor. Integrated solutions provide you with a rich feature set, pre-integrated and tested, and comes with a single point of support. This is your traditional GNOS and iOS. In the middle, what you see is the open networking. It's disaggregated hardware and closed software. Open means choices and options. It provides you with the power of choices. Organization can achieve greater benefits by choosing the best of the breed open networking hardware and software. It's cost efficient as well. Let's say, for example, currently you have a TOR use case in a campus today. Later, you are switching to your data center use case. You can repurpose the hardware. You are with vendor A software today, and then they didn't meet your new use cases. So you can move to a vendor B software. That's the power of choice open networking brings to you. On your right, what you see is your open networking 2.0. This is where the industry is moving towards disaggregated hardware and open modular software. To understand this, let's take an iPhone or an Android analogy. You have a different hardware platforms from vendors like Samsung, LG, etc. They have an abstracted infrastructure like Android OS and SDK. It provides an application developer who writes apps without worrying much about the underlying hardware. For the end user, it provides with a choice of application. They can pick Gmail today and then later switch to Outlook. Similar in networking, we are coming with a common abstraction for platform and switching ASICs. So the developer can write their application without worrying much about the underlying networking hardware platform. For the end user, you can choose the application need based on your use case and budget. For example, the top of rack and spine, you can go with open source FRR, and for your core, you can go with Juniper CRPD application. This brings you accelerated innovation and simplification. All the application components can be iterated independently, providing innovation and development speed. Question to you all. How many open networking operating systems do you think there are currently available? I have captured approximately 16 vendors in software open networking and 12 vendors in the hardware. I am pretty sure there are more vendors. I would have missed some of the logos. I apologize for the same. You can see the power of choices it brings to the networking industry. Also, you can see all the major traditional vendors moving towards open networking. I just wanted to highlight that open networking is already here and penetrated in majority of the use cases. We need to understand the components of a traditional network operating system. This is critical in order to understand the various choices of open source network operating systems available to us. This slide shows a block diagram of your traditional network hardware and software for a pizza box architecture. Chassis will look similar with additional components. I'm going to request you to take a mind dump of this block diagram. We are going to see this picture over and over again to compare and contrast the different open source operating systems available. So what you see in the bottommost is your hardware, networking hardware. It has CPU, peripherals like fan, power supply, and everything, and then your NPU and switch ASICs, which provide the I/O for the packets. On top of that, what you have is a bootloader to boot your network operating system. On top of that, what you see is your network operating system itself, your traditional OS. So typically they use Linux or NetBSD as a traditional operating system. Then you have the drivers for your peripherals, an NPU, etc. And what you see next is the abstraction layer. It is a critical layer which provides abstraction to your NPU and platform switches. As we saw earlier, it helps the vendors to provide you with the more choices of hardware and the application developer a common interface to develop their application without worrying much about the underlying platform or switching ASICs. And what you see on your left is the infrastructure layer, which provides you login and inter-process communication, which are required for the application to communicate between themselves. And next comes the control plane layer, or a protocol or application layer. It provides you various protocols required for the network operation like BGP, STP, LACP, etc. The final layer is your management layer, which provides different northbound interfaces like CLI, SNMP, NetConf, REST, and GNMI to provision and manage your network devices. This is what a typical traditional network operating system consists of. These are some of the main networking components which helped us to create the open source NAS we are going to see today, ONI. It is a bootloader used in all the open networking hardware. It provides a modern and efficient network install environment. It is part of the Open Compute subproject initially contributed by Cumulus. It is a small operating system by itself and provides an environment for automated operating system installation via zero-touch provisioning. It became the de facto bootloader for networking and currently supports approximately 161 devices. Open Networking Linux. It is a distribution of Linux which mainly provides a platform abstraction via its ONLP API. It also part of the Open Compute project. It is a reference NOTs used to certify the OCP compliant hardware. It has becoming the de facto standard for platform abstraction and currently supports 120 platforms. It uses Debian based on stock LTS kernel operating system. We'll look into it this later, since this is one of the open source NAS we have to see. Switch abstraction interface. It provides a vendor-independent network abstraction API to control your forwarding elements like NPU, switching ASIC, and software switch. It provides abstraction for all the major switch vendors like Broadcom, NANOG, and Innovium. It provides an extensible API and follows a simple entity attribute value data model. SAI helps easily port it to a new ASIC by providing a simple and consistent programmatic interface for the application developers. Switch step. It provides network abstraction as well via an in-kernel network driver for switching ASIC. It has a different philosophy, like when you buy a laptop or a server, vendors provide the NIC driver. Similarly, the switching ASIC or NPU vendor will provide you with the NPU or ASIC driver for the OS, which offloads the L2, L3 forwarding plane to the ASIC. Currently, it is supported only by Benelux. So with this model, you take a supported platform, install a Velina Linux, and use the corresponding switching driver provided by the vendor. It will offload the L2, L3 forwarding functionality to the switching ASIC. You can simply create a bond or VLAN or route in a Linux, and it will be programmed directly to your switching ASIC. OpenConfig. Till now, we have seen abstraction at a lower layer. OpenConfig provides a higher layer management abstraction. It provides a vendor-independent data model to provision and manage your network devices. Its initial models are contributed by Google and other network operators. Currently, all the major networking vendors support OpenConfig models. It enables to write a common management and controller applications for your network devices. You can use this model with the modern network management protocols like REST, gRPC, and NetConf. As you can see in the slide, the open networking components we saw in the previous slides provide some of the components needed to build the NAS along with others. So as you can see, ONI provides you the bootloader, and traditional Linux provides you the operating system and the infrastructure components. SAI and SysDev provides the network abstraction, and ONL provides you the platform abstraction. And Linux open source applications like FRR, Bird, GoBGP, TeamD provides you the application layer required. And the OpenConfig provides a common abstraction for your open source management application with Swagger and Conf and YDK, etc. Open source network operating system developers or uses these blocks we saw earlier and fit them like a Lego block to create their open source NAS. Most of the operating system we are going to see today uses Debian distro and stock LTS kernel. On top of that, they use one of the platform and NPU abstraction we saw, like SAI or system. Combined with the open source application stack like FRR, GoBGP, they solve today primarily the data center leaf and spine use cases. This is a landscape of open source network operating systems. I tried to capture most of the operating systems here. So on your left, what you see is a winding down operating system. On the top, we have LibreSwitch by HP. It is a fork of initial OpenSwitch project. On the bottom, what you see is FlexSwitch by SnapRoad. I'm sure that some fork of them are still being used in the industry today. On the middle, what you see is the present operating systems. Open Networking Linux, OpenSwitch, Sonic, and Stratum. These are the present operating systems available to you today. If you want to go home to build a network, these are the choices you have. We'll go over this NOS in the upcoming slides. What you see in the right are the upcoming OSs, Danos and Dent. Both of these projects are under Linux Foundation. Danos is backed by AT&T. Viata OS provides a seed code to it, mainly focusing on telco use cases. Amazon and Cumulus Mellanox, along with other partners, recently announced Dent, focusing on the edge and IoT use cases. It is based on Linux and SwitchDev. Open Networking Linux is a foundational platform software layer in a modular NAS architecture. ONL is a part of Open Compute project and is a component in a growing number of commercial NASs. Stacks like Arcus, Big Switch, and open source projects like Card and Stratum. This is what a traditional NAS is. This is what ONL provides. And this is how they define their architecture. As you can see, it misses a lot of components. When a user tries an open source NAS, they expect it to be equivalent to traditional NAS. That's where the frustration stems from. Basically, ONL provides the end user with the power of choices to build their NASs. It mainly provides the platform abstraction and provides multiple choices for your control and data plane. As you can see, it provides you OpenNSL, SAI, and OFDPA for your data plane abstraction, and it provides SnapRoute, FBOSS, Indigo OpenFlow Agent, Big Switch Lite operating system as your control plane functionality. So the user can build this as a thick OS with FRR and Open Route Cache, or a thin OS with a SDN controller like ONAS based on their use case. Currently, it is used in the CARD project using ONAS SDN controller with the Indigo agent, and in some cases used as a thick OS with GoBGP Zebra for a UVPN use case. And it is used in a leaf and spine fabric use case with Facebook FBOSS. OpenSwitch. OpenSwitch is a disaggregated network operating system to build your composable networks. It's currently under the Linux Foundation. One thing I want to call out is Open vSwitch is not OpenSwitch. Open vSwitch is a different project which provides a host-based networking stack. OpenSwitch, along with the other NASs we are seeing today, are primarily developed to run on your traditional bare metal switches. So this is what a traditional NAS components looks like, and this is what OPX provides, and this is how OPX defines their architecture. As you can see, it provides only the platform abstraction and network abstraction along with the model-driven API to program the platform and NPU. Again, it provides you with the power of choice of application. By default, it supports Linux applications like FRR. It is similar to the analogy we discussed earlier with iPhone and Android. Right? OPX provides you with the required abstractions and the model-driven API so that the user can build their own application if needed, or they can use the standard Linux applications. So I have seen a load balancer and security application built on top of OPX. It is used as a base operating system for commercially available Dell EMC Smart Fabric OS 10. What it means is we have used OPX as a base OS. On top of that, we have put our closed source enterprise grade application. It is already in production at various data centers like Verizon. These are the features supported in OPX. I'm not going to go through them. As you can see, it supports all the protocols required for building a leaf-spine fabric data center. SONiC is a modern open source network operating system based on Linux. It follows a modern database-centric and microservices-based architecture. It is part of Open Compute sub-project. This is what a traditional NAS is. This is what SONiC provides. And this is how SONiC defines its architecture. Unlike the other operating system we saw earlier, OpenSwitch and ONL, SONiC offers a full suite of network functionality. SONiC has been production hardened and deployed in some of the largest cloud service providers like Azure, Alibaba, and some enterprises like Comcast. It offers organizations the flexibility to create a network solution they need while leveraging the collective strength of the larger ecosystem and community. Recently, for edge use case, we've created a container and hosted alongside with SONiC, the canonical metal as a service, to set up the edge infrastructure. So SONiC has gained wide industry support over the last year that includes major networking chip vendors. If you look at the major contributors, Microsoft, Dell, Broadcom, Mellanox, it will be clear to you. Currently, it is supported by Dell Technologies and Mellanox. These are the features supported in SONiC. As you see, it supports a lot more feature set required for building a data center and enterprise use case. It leverages the collective strength of a larger ecosystem and community to provide you with this rich feature set. It is the first operating system to support in-band telemetry. Stratum is the next-gen SDN solution. It is an open-source switch-independent operating system for software-defined networks. It is part of Open Networking Foundation. This is what a traditional NAS looks like. This is what Stratum provides you. This is how Stratum defines its architecture. Similar to OPX, it provides a platform and network abstraction along with a model-driven API. Unlike OPX, the API provided by Stratum can be controlled externally using the modern gRPC interface so that it can be used by the SDN controller. Stratum defines a three set of standard and extensible APIs, GNMI, GNOI, and P4 runtime APIs. GNMI provides a standard open config-based network management interface to provision the network operating system. GNOI defines a set of standards for network operation interface to manage the device. And P4 runtime API provides a standard API to dynamically reprogram your switching ASIC pipeline. With the growing number of programmable hardware coming to the market, it allows you to dynamically reprogram ASIC pipeline based on your use cases. The seed code for Stratum is provided by Google. As you can see, similarly, Stratum can support both the thin OS with the SDN controller or a thick OS with the applications like FRM. You can either use a proprietary controller or an open source controller like ONAS. Currently, they are focusing on SDN-based use cases for telco. We have seen the open networking and open source NASs available to us. This slide captures the applicability and deployment of them in various use cases. As you can see, open networking OS has penetrated almost all the use cases, like data center, access, aggregation, etc., not in core yet. Similarly, open source networking is started to penetrate primarily in data center, leaf-spine use cases. They are slowly moving towards access and aggregation. The journey so far. Open networking journey started from hyperscalers, trickled down to service providers and enterprises. Open networking solutions are deployed in all the major use cases today. Similarly, the open source network operating systems are currently deployed by large hyperscalers and service providers, and it is slowly trickling down to the enterprise use cases. I definitely believe we are in an open source era of networking. What are the challenges and calls to action to us? Whenever we think about open source, the first thing comes to our mind is support. In case of traditional operating system, the support is provided by a single vendor. In case of open networking, we still get the support from the hardware and software vendors. In case of this open source NASs, where we'll get the support from. We have started seeing some partners support this NASs. Recently, Dell Technologies announced their enterprise distribution of SONiC. Similarly, Mellanox said they will support SONiC as well. I see some of the other partners trying to support other NASs as well. This ecosystem will continue to grow. Quality is one of the other concerns we have when we go for an open source project. But most of the NOSes we saw today are already deployed in production. To take an example, Sonic powers Azure. Also, some of them are already part of a commercial NOS. If you take ONL, they are part of CUS and SnapRoute. If you take OPX, it is already part of Dell EMC's Smart Fabric OS 10. Also, there is an increasing focus on quality on these open source NOSes. If you have attended previous OCP or ONS, you have heard Microsoft talk about increasing Sonic's quality in OCP and Stratum's test-driven approach to qualify the API interfaces. We already have certification in place for ONI and ONL, and similarly for rest of them, eventually the certification process will trickle in. Call for action. Deliberately, I left out the comparison. I wanted you to go back and understand the choices you have. Based on the use case, you can pick and choose the OS what you want. By looking at their community support, it is important for you to look at the community support because that's what tells you whether this open source project is a viable option for you or not for moving to production. Test drive. All the OS we discussed today comes with the virtual environment. So you should be able to spin them up and take it for a test drive. Once you're comfortable, then you can start deploying them on a non-production environment. Then in a small controlled production environment. I'm pretty sure this modular open source operating system will be able to lend itself for your use case. With that, thanks for listening in. Hope you would have now have some clarity on the open source noise choices available to you. I'm happy to take any questions in the Zoom Q&A. Thank you.
And Phil, thank you very much.
Thank you.
Only just one request, if you can speak a bit closer to your microphone. Okay. Thank you very much for the talk. There is quite a few questions actually for you. I'm going to start with, as they were restated, with the oldest one. So the first question is, do you have any suggestions on how to try any of these systems out in, say, Docker or Vagrant?
Yes, actually, can I share my screen? Okay. Oh, they won't be able to see it? Okay. I'll post some links in the chat or the Q&A. There are options to run them in the Docker or Vagrant. Both the OSs, Sonic and OPX, they all provide Linux VM images as part of the daily builds. So you should be able to take the ONI installer, like how you typically install the OS in an open networking switch using ONI. So you have a ONI ISO image which you can boot as a VM, and then install these binaries or Sonic or OPX .bin or ONI compatible installers in the VMs, and you can use Vagrant to bring them up. And OPX actually provides a Vagrant environment by default itself.
Thank you.
Does that answer the question?
Let us know in the comments if it does or not. So, next question is, how interchangeable are the various components really? Does, say, FRR work as well as excuse me, as OpenSwitch as it does in Sonic, or are certain NOSs typically paired with particular components?
So it depends actually. It depends on the OS you're talking about. If you take the case of OpenSwitch, it doesn't have any tie-up with the application itself. So basically, when you replace another NOS which supports the routing via your Netlink API to program, OpenSwitch does that. So you can replace your NOS which has the same principle. If you showed a live in the OCP demo where they can switch between stacks, but with the recent developments of Sonic, it is tied into the FRR is even more tied into the backend. In that case, moving that, replacing that, it's still possible. It's not a quite difficult task, but it still needs some work. It's not a straight replace in that case.
Thank you. The next question is, do you predict that, like Libre suites and Flex suites winding down, current and upcoming open source network operating systems will follow the same pattern?
It actually depends on how the community support is there. But if you look at what happened to Libre Switch and the other one, the Flex one, the company which backed them, right, HP and Snap, operating systems, either Sonic, OPX, those are all actually moved under foundation right now. Both ONL and Sonic are in Open Compute Foundation, and OPX is in Linux Foundation. And those are all part of already, as we talked in the presentation, they are all already part of a commercial node somehow. And then right now, with the growing community of Sonic, I think that Sonic will not see that light in the sense that it won't wind down, is what I'm guessing right now. The current steam on Sonic.
Thank you. Next question is, do you foresee other chip vendors besides Mellanox supporting Switch Dev?
Yeah, so it will eventually push, it's up to the new vendors, right? Like Innovium and so right now, Broadcom does support Switch Dev, but those are in the home routers, right? Eventually, based on the market push, how it comes out in the near term, right? It recently announced Dent from Amazon, Cumulus, and NANOG and other partners. They are talking about using Switch Dev completely, right? Once the momentum kicks in, the vendors will be forced to develop something for that.
Thank you. Next question is, why is Sonic considered open source? Its SAI code is a closed source blob. How does this differ than other vendors listed as closed?
No, when you take SAI blob as a closed source, but if you look at the other vendors, when I mentioned Cumulus as a closed source, what I meant is you don't get your the core of the switch agent, which has in Cumulus is not available for you for open source, right? When we say SAI can still be open source when they use the open source API provided from the vendors. So if you have Mellanox, they have their API openly published. Right? If the SAI is ported via that API, it still completely can be open sourced. And again, with Broadcom, they right now recently announced their SDK LT, which is an open source API for them. One open source as well. So if you take Sonic, all the complete code is in open source. If you take Cumulus, all the code is not in open source, right? That's what I meant by closed source and Sonic as open source. We are moving towards there. Hopefully, the SAI drivers also will be open sourced. So.
Great, thank you. Next question is, how does the cost of staff to support NOSs compare to the cost to purchase software licenses and support from vendors? When do the benefits of the flexibility of NOSs become attractive / cost justifiable? How do they compare?
Amount about that actually. Typically right now what we are seeing, at least in the field, what I'm seeing in the production right now is whoever is a large scale vendors who can support and maintain the open source NASs are going towards the direction. You have to weigh in the cost it takes to run an open source networking operating system, right? You don't get the same level of support, so you need to have the expertise built inside the team itself in order to take the first shot at what's going on. So fortunately, so for all those open source NASAs right now, the vendors are coming up with the support. So as we talked in the presentation, Dell Technologies recently announced their complete support for Sonic, and Mellanox also recently announced their support for Sonic as well. So that way you'll still get the support what you require, but for a little bit of lesser cost compared to your traditional NASAs.
Okay, thank you. 3 more questions. Can you speak a bit more about the use of OS and OSs in optical interconnect?
Actually, I don't have much knowledge on that. I know that recently in the optical interconnect, in the TIP project, they recently announced a new open source NOS in the TIP as well. Other than that, currently I'm not aware of the optical interconnect area. Sorry about that.
That's fine, no worries. Next question is, any chance we could see more support for these NOSs on smaller Dell devices that could be used for home labs?
For using in the home labs, actually all this NOSs can be supported today in a small VM or a Intel NUC kind of environment. If you have it bigger compared to OPX in the size of image, it's currently at 2 gig, I believe. So as long as you have a 4 gig RAM system, you should be able to try it in your home lab easily. In case of Sonic, you can turn down the containers which you are not using, so that you can reduce the memory footprint in Sonic.
Great, thank you.
So actually, I run multiple NOSs. My laptop is 16 gig, at least I run multiple NOSs in that. Sorry? In my laptop, I have 16 gig of RAM. I was able to run a 4-node topology of OPX and Sonic. So you should be able to run in a smaller RAM system as well.
Excellent. And last question. Can any of these commercial grade open source systems be changed to talk to the switching hardware used in consumer grade routers? Or is anyone looking at doing this to make prototyping easier?
Sorry, can you repeat the question? Anna?
Sure. The question is, can any of these commercial grade open source systems be changed to talk to the switching hardware used in consumer grade routers? Or is anyone looking at doing this to make prototyping easier? Can any of these commercial grade open source systems be changed
I
to talk to the
understand the question clearly.
You can ask for a clarification. Could the person who posted this question?
I don't understand the question actually. When you say commercial grade open source, yeah.
Yes, if we can have a clarification in the question box for this question. Can any of these commercial grade open source systems be changed to talk to
what do you mean by the consumer grade routers? I don't get the point of consumer grade routers. See, any of these commercial grade open source network operating systems, right? So what it needs, as we saw all the NAS components, right? You have a abstraction layer at the end. So in case of NAS abstraction, we saw SwitchDev and SAI as a couple of options for it, right? As long as you have a API layer written for your the abstraction layer, you should be able to run on the others using SAI code as a blob, as we previously mentioned, right? To most of the routers available. So if they already support this package, So you should be able to take that SAI code and then you should be able to build it out or the POC.
I think we got the clarification. This is from Scott Dorsey. He says, what if we want to run the OS on a chip Linksys router, for instance, for prototyping?
Yeah, you can do that, as I said, but you need to know the underneath hardware APIs, right? So you need to know that the SDUs, you can port only the APIs which are required for SAI, to give an example for SAI, right? You can just port those APIs. And if it's the home routers, most of the home routers are actually right now trying to provide the switch dev kind of API because it's much more easier to install a Linux environment rather than you trying to do. So you can check whether your Linksys router has a switch dev driver available. If that is available, that would be a straightforward way for you to achieve, because I see that couple of home routers I have from Broadcom, they have a switch dev support.
So is just one last question. Is this for any router we can buy from Best Buy, for example?
As I said, right, if you buy any router from you need to know underlying, right? It's not that straightforward. So you need to understand the code and the API for that, right? As long as you have the API ported to configure the VLAN, for that, it's possible. Let's say that you have a UI interface or REST interface, that is also sufficient for you to call. When a port create happens, you can call the API for the SAI port create to go and link to your switch router, right? So that tie-up has to happen to the router drivers, right? Either it can happen, as I said, from either SAI or switch dev. You can check whether any of the routers which you guys get from Best Buy, I don't have the name right now, supports a switch dev, then you can try it out.
Excellent. Thank you very much. I think this is the end of the questions. I don't see anything else. So we can conclude the session here. I think that leaves us, let me see.
Yeah. Thanks all for attending the talk.
We're almost out of time anyway.
Hopefully, you got a little bit of into open source networking.
Yeah. So I just want to say, just to close the session here, remember there will be a poll at the end of this session for both topics for tomorrow. Please enter your choice, and we'll make a selection for tomorrow's breakouts. Thank you very much.